How rockets work, the science of space travel. Space travel is one of humanity's greatest achievements. From launching satellites to sending astronauts to the moon, rockets are the key to exploring the universe. But how do rockets work? What principles of physics allow them to escape Earth's gravity and travel through space? Let's dive into the science behind rocket propulsion and space travel. Rockets operate based on Newton's third law of motion, which states, for every action, there is an equal and opposite reaction. When a rocket burns fuel, it expels hot gases at high speed in one direction, downward. As a reaction, the rocket is pushed in the opposite direction, upward. This force is called thrust, which is what lifts the rocket into the sky. Key physics concepts in rocket motion. Thrust, the force that pushes the rocket forward. Drag, the air resistance acting against the rocket. Gravity, the force pulling the rocket back to Earth. Lift, forces that help the rocket maintain stability. Without air resistance in space, rockets don't need wings like airplanes. Instead, they rely entirely on the thrust from their engines. The stages of a rocket launch. A rocket launch is a step-by-step process involving multiple stages. 1. Liftoff. At launch, the rocket engines fire up, producing enough thrust to overcome Earth's gravity. The first stage contains powerful boosters filled with fuel. Fuel used, liquid hydrogen and oxygen, or solid rocket fuel. Key challenge, must generate more thrust than the weight of the rocket. 2. Stage separation. Once the first stage burns out, it detaches, and the second stage engines ignite. This process is crucial because carrying empty fuel tanks would make the rocket too heavy. Why staging? It reduces weight, making the rocket more efficient. Example, SpaceX's Falcon 9 rockets have reusable first stages. Path 3. Reaching orbit. As the second stage burns out, the rocket enters low Earth orbit, LEO, or moves towards its target in deep space. Orbital speed. Rockets must reach at least 28,000 kilometers per hour, 17,500 miles per hour, to stay in orbit. Why so fast? Without this speed, Earth's gravity would pull the rocket back. Once in space, the rocket can perform different maneuvers depending on the mission. Some rockets release satellites, while others send astronauts toward the moon or Mars. In orbit, astronauts experience weightlessness. Small engines help adjust direction and speed in space. Re-entry and landing for reusable rockets. Modern rockets like SpaceX's Falcon 9 and Blue Origin's New Shepard return to Earth and land vertically for reuse. Rockets come in different designs based on their purpose. Why rockets work differently in space. 1. No air in space equals no lift. Unlike airplanes, which need air to generate lift, rockets work in space because they carry their own oxidizer, oxygen source, to burn fuel. Once in orbit, astronauts feel weightless because they are in free fall around Earth. Fact: the International Space Station, ISS, is constantly falling toward Earth, but its speed keeps it in orbit. In the future, rockets may use warp drives or antimatter propulsion to travel between stars. The future of rocket science. The future of space exploration depends on new rocket technology. NASA and SpaceX are working on Starship for Mars missions. Companies like Blue Origin and Virgin Galactic are making space travel accessible. Nuclear-powered rockets could make interplanetary travel faster and cheaper. Rockets are one of humanity's greatest engineering achievements. Whether it's launching satellites, sending astronauts to Mars, or exploring the far reaches of the universe, rockets turn science fiction into reality. Would you like to travel to space one day? What destination would you choose? Let us know in the comments.